The Astrogeology Research Program is a program of the United States Geological Survey concerned with the study of planetary geology and planetary cartography. It is housed in the USGS Astrogeology Research Center in Flagstaff, Arizona. The center was established in 1963 by Eugene Merle Shoemaker to provide lunar geologic mapping and to assist in training astronauts destined for the Moon as part of the Apollo program. Since its inception, the program has participated in processing and analyzing data from various missions to the planetary bodies in the Solar System, assisting in finding potential landing sites for exploration vehicles, mapping our neighboring planets and the moons, and conducting research to better understand the origins, evolutions, and geologic processes operating on these bodies. The early days. Eugene Shoemaker founded the Astrogeology Research Program August 25, 1960. The research program started out as the Astrogeologic Studies Group at the United States Geological Survey Center in Menlo Park, California. The research program was moved to Flagstaff, Arizona. Flagstaff was chosen as the location due to its proximity to meteor crater and the volcanic craters and lava flows of the San Francisco volcanic field. Dr. Shoemaker retired from the USGS in 1993. He remained on emeritus status with the USGS and maintained an affiliation with Lowell Observatory until his death in a car accident in Australia in 1997. Eugene was involved in the Lunar Ranger and Surveyor programs and continued with the manned Apollo programs. He culminated his lunar studies in 1994 with new data on the Moon from Project Clementine, for which he was the science team leader. Eugene collaborated closely with his wife, Carolyn, a planetary astronomer. The discovery of Comet Shoemaker-Levy with colleague David Levy gained them worldwide fame. This was just one of Eugene's many great accomplishments. Starting in 1963, the Astrogeology Research Program played an important role in training astronauts destined to explore the lunar surface and in supporting the testing of equipment for both manned and unmanned missions. As part of the astronauts' training, USGS and NASA geoscientists gave lectures and field trips during the 1960s and early 1970s to teach astronauts the basics of terrestrial and lunar geology. Field trips included excursions into the Grand Canyon to demonstrate the development of geologic structure over time, Lowell Observatory and Kitt Peak National Observatory, Meteor Crater east of Flagstaff, and Sunset Crater Cinder Cone and nearby lava flows in the Flagstaff area. This training was essential to giving astronauts the skills and understanding to make observations about what they would see on the lunar surface, and to collect samples for later study back on Earth. The volcanic fields around Flagstaff have proven particularly useful in testing equipment and training astronauts. Cameras planned for use in the Surveyor project were tested on the Bonito Flow in Sunset Crater National Park because the lava flow appeared to be similar to flows on the lunar surface. A field of artificial impact craters were created in the Cinder Lakes volcanic field near Flagstaff to create a surface similar to the proposed first manned American landing site on the Moon. Jack Schmitt joined the astrogeology team as a geologist at the Flagstaff Science Center in 1964, having recently earned a doctorate degree from Harvard University. In addition to assisting in the geologic mapping of the Moon, he led the Lunar Field Geological Methods Project, When NASA announced a special recruitment for scientist astronauts in late 1964, Schmidt applied. Out of more than 1,000 applicants, 6 were chosen. Of those 6, Joe Kerwin, Owen Garriott, and Edward Gibson would fly in the Skylab missions in 1973 and 1974, and Schmidt would go to the Moon on the Apollo 17 mission. Astrogeology Today. The mission of the USGS Astrogeology Research Program is to establish and maintain geoscientific and technical expertise in planetary science and remote sensing to perform the following tasks: scientifically study and map extraterrestrial bodies, plan and conduct planetary exploration missions, and explore and develop new technologies in data processing and analysis, archiving, and distribution. The program's efforts are concentrated in 3 general areas: studying the origin and evolution of the planets and satellites in the solar system, specifically the geologic processes operating on these bodies. Developing increasingly sophisticated techniques of remote sensing and image processing to be used in the interpretation of planetary surfaces and processes and in terrestrial ground and space studies, and producing mosaic images, maps, and other cartographic products for the scientific community and the general public in support of terrestrial and planetary geoscientific studies. The USGS Astrogeology Research Program participates in all phases of flight mission support through providing scientific input for mission planning, creating precise planetary images and maps, and supplying landing site maps and characterization. Historic, recent, ongoing, and upcoming space missions involving the USGS Astrogeology Research Program include